Okay, so I guess we'll go ahead and get started. Let's first take a look at what we've got coming up. So let me share my screen. Right, can you all see my screen?
Yeah.
Cool. Okay, so today, hang on. I gotta get everything arranged so I can see you guys. Okay, so today is the 17th. We are here in class. We've got our first quiz coming up on this. I'm going to push this back because we are going to get to this in just a little bit. I think we'll probably start this next class. And so I want to balance. I want to make sure we obviously cover the content before we get into it. So I am going to, we might even wait until next Tuesday to cover that. So I'm going to push this back a little bit. Right now, I'm just going to push it back a week because I want to have enough time to go through object-oriented program design. Overview wise, we're going to spend a good bit of time in the code for that meal maker application. And so I don't want to do it all right now, but I want to get into it enough to give you guys a little bit of information about how to start setting up your program, rather than waiting to do all of that later. At the same time, I also want to balance introducing you into the new content, the SDLC, which is the software design lifecycle, and the content that you need for the quiz portion and that sort of things, the UML diagrams. And so I want to kind of balance introducing information on how to set up your program with kind of theory stuff. And so I think we'll spend today and maybe one more class period on showing you guys how to set up your programs, how to get started. And then we'll kind of we'll transition into documentation and that sort of thing, which is just as important. But the last thing that I want is for you guys to start your programs and code yourself into a corner where you feel like you need to start over once I show you. This is the general way that a program should be set up when we're talking about a larger scale application. You're like, oh crap, well, I did the complete opposite. Now I have to start over. I want to avoid that by giving you guys a little bit of information up front, enough to get you started, and then we'll kind of revisit some of the more advanced object-oriented concepts once we get the documentation done. Does that make sense? You good with this? Okay. All right, so today we will kind of pick up where we left off. And so you'll see in the modules two things. One, if you go to Zoom and then you go to previous meetings, maybe it's in cloud recordings. I have to publish these. Okay, I think that's it. If you go to previous meetings, you should get access to the videos. Also, what I'm doing is I'm putting them here as well. They're a little bit more organized this way. And so you can see exactly what it is that you need. So here's the very first video that we did, the introduction. And then here is what we did last class, where we first started diving into that meal maker program. And that's where we're going to pick up as well. Also, I gave you access to the entire project. So if you want to follow along on your own, more than welcome to. And in fact, I've divided up into two things. This is the complete Unity project. Okay. This course isn't a Unity course. Okay, and so I don't expect you to have knowledge of Unity, download Unity, do anything related to that at all. If you want to, though, I've given you the project, so you can follow along exactly with what I'm doing. Second, I have given you just the scripts only. So if you want to just look at the code, you can download this. If you don't want to mess with Unity at all and you just kind of want to reference the code and the classes that we are going over, I've uploaded just the code for it. So you can grab the scripts only zip from there. So the complete project contains the scripts, but if you don't want to mess with Unity at all, you can just grab it from there. Okay. Any questions on that? Cool. Okay. Well, let me get it pulled up. Where did we leave off last time? With I think the GUI manager, is that what we started? Oh, we were talking about singletons, weren't we?
Yeah, singleton.
Okay. Gotcha. Okay. So, all right, so generally speaking, the way you want to have your program set up is you obviously have one class that has some sort of method or function that gets called automatically when your program runs. That class generally will be responsible for initiating all of the other classes that you have. And I've got something similar with this like that. And so we looked at the GUI manager last time. Let it load. That is not the right window. Okay. We looked at this last time. Okay. And we're going to pick up where we left off here with the idea of a singleton and why the idea of a singleton is useful and in what situations we would use it. So first of all, big picture wise, and this is kind of a review of what we did last class. A good way to set this up is by having like a manager script at the top that has access to all of the other ones. Okay, so for example, here we've got a GUI manager script. All right, and this is going to be responsible for managing each of the individual windows. And each of those windows has their own manager script. But the way that we access those individual ones, okay, and we see like you have main menu, meal menu, all of the different kind of sub windows, all of those are going to be here. Okay, so this is where we have the main menu manager. This is where we have the meal menu manager. These are all separate windows. Okay, this would be side item manager. We don't have to go through and actually write these all out, but I want you to understand big picture wise, this is how the program is set up. We have a single access point, which is GUI manager. And using that single access point, we get access to all of the individual menus. Okay, that's how this is set up. All right. Now, the GUI manager is set up as a singleton. And so we're going to spend the first bit of today talking about what a singleton is. Now, the main definition of a singleton is that design pattern forces a single instance of the class to exist. Okay, and so if you think about it, again, we talked about this last class. With a singleton, it kind of breaks the normal object-oriented approach where you have a class and then you create a bunch of objects from that class, and each object uses encapsulation, which means it manages its own data and doesn't mess with other objects' data. With a singleton design pattern, you know you're only going to have one instance, okay? And because you're only going to have one instance, that instance is going to be marked as static. And the reason for that is because it's static, we can now access that single instance using the class name rather than having to initiate it and access it with either a reference variable or a pointer, depending on the language. Okay, now let's talk about the code for how that's done, and let's talk about how we force a single instance. Okay, so first of all, we're going to have to modify this code a little bit. So here's our singleton. And we have it marked as static. Remember, static means that this particular value is going to get created only once, and it's going to be at the class level instead of the object level. You can also access, because it's at the class level, you can access it using the class name. So because it's public, at any point in any other script, we can say GUI manager.instance to get access to this. And that is the main benefit to doing this. And we'll look at practical applications of that in just a little bit. Now, here's how it's created. We talked last class about the fact that Unity has some built-in functions. Okay, and this awake function is the same thing as start. And what happens here is the awake function gets called once right when the program runs. Okay, and it gets called before start. So awake happens, and then a little bit later start happens. Okay, so this gets called once right at the beginning of the program, very similar to like a main method in Java. Okay, now here's the code that we have to do. Okay, essentially what happens is the way that we force this to only create one instance is to set it up to check to see if the instance exists already. Okay, this could really also be done inside of a constructor. And so if you think about it, a constructor gets called whenever a new object gets created. All right, so if we were going to create a constructor for this class, it would look like this. We would say public GUI manager, and then we might have some variables here, but not necessary. Okay, so this is a constructor. We could do it like this, but it's better. We want it to happen automatically, which is why we have it in awake. You could also have it set up to where this gets called inside of a main method if you want to have everything done through there. Because Unity has these functions that automatically get called, we don't need to do that. In Java or C#, you've got a method that automatically gets called from your main script that you run. And from there, you would instantiate the singleton, and you would put this code inside of a constructor. That's how that would work. But this is essentially the same thing. So here's how this works. We know that this is going to get called once at the beginning, but we want to make sure that it never gets called more than once. And the way we do that is by using this instance variable. And so we're going to say if instance equals null. Okay, and this means the singleton has not been created yet. Okay, are we good so far? If instance is null, which we expect it to be at the very beginning of the program, then the instance or the singleton hasn't been created yet. Okay. In that case, what we want to do is we want to set the instance to be this. Okay. Now, again, look, instance has a type GUI manager. This is a keyword that references this class. Okay, and so what we are doing is we are setting the instance to point to this. Okay. Questions so far? Okay. So this is null. This can't be null by definition. Okay, so let's I'm getting that's correct. Let's do a quick review on this. This is a keyword that refers to the actual instance where we are. And so in this case, this refers to the exact instance of GUI manager that's inside of this method, okay? Which, because instance is static, refers to the GUI manager class, okay? Full disclosure, this will make your brain hurt. Singletons, until you get used to it, will hurt your brain. So just go with it for a little bit. Please ask questions, but know up front that they're confusing. And so if you're like, I have a hard time putting my head around this, that's normal and it's going to happen. Just stick with it. It'll all come together. Okay. So if instance is null, meaning we haven't created the singleton yet, we'll go ahead and create it. And the way we create it is by setting the single instance to be this class. Okay. And the only time that can happen is if instance is null. So if instance is null, then we set instance to be this class. So at that point, from that point on, this will never get run again because we gave it a value. And so this could never be true after the very first time. Does that make sense? Okay. Now, if we get to the else statement, that means the singleton exists already. Do not create a new one. Okay. And so what we could simply do in that case is, depends on the language, I'll say this. You could simply do, what you would want to do is you want to destroy this new one, okay? Because if you think about it, essentially what we have, I need like a whiteboard. Hold on, I'll be right back. Okay, I'm back. Everybody still awake? Okay, so here's the idea. We'll do it like this. We have GUI manager. Okay, and then we have this outside call to create an instance. Okay. When this happens, essentially what we have is we're going to create the instance here. Okay. If ever we get another call to create an instance, we're going to check to see if this exists already. If it does, we want to delete this. Okay, so if we think about it, like if we have a bunch of calls to create instances, each time a call happens, if this exists already, we want to delete the new ones so that they don't actually get created. All right, so big picture wise, this is what we're doing here. This is the way that we force a single one to exist. We first check, does one exist? If it doesn't, we go ahead and create it and set it to that one. Okay. If we call it and one already exists, we want to delete the one that's trying to be created. Okay. So if a new one tries to get created and one exists already, we've got to delete that one. Okay. So that's what we're going to do here. Depends on the language. Yes, the XO instances, that's correct. Sorry, I'm reading chat. depending on the language, you're going to destroy it differently. So you see what I did there? This is how I always spell destroy. It's awful. I have so many bugs because I always spell destroy wrong. Yeah, every time. It's my fingers betray me. That and I can't spell. So this is the basics of how do you destroy in Java? That's a good question. Where's my thumb down? Hold on. Oh. See, I can thumbs down too. So it looks like you can do this. So let's see how we do this in Java. All right, so if we look at this, notice the static. Final simply means that it is a constant and it can't be changed. Okay, so it looks like the way they're doing it here in Java. And again, and this is important. And this is one reason that I'm showing you guys this code and not really worrying about the language or the software that's used, because the whole idea is that we want to be teaching you concepts, not necessarily individual languages. And so I want to teach you the concept of a singleton, which I think we've gone over, the idea that a singleton design pattern means we are forcing a single instance of a class to persist throughout the whole program and not allowing more than one instance to exist. That's the concept. Now, the implementation is going to be different depending on the language. And so what I did was, okay, I'm familiar with singletons, but I've never done a singleton in Java because I don't code in Java most of the time. And so I simply looked it up, and we can use the knowledge that we have to apply it and figure out how we do it in a different language. And so the way they're doing it here is they are initializing it when the variable is declared. Okay, so we are creating a new one here. Looks like they override the default constructor and make it private so that you can't actually create an object of it, which is a good idea. Like this literally prevents you from calling the constructor method because they force it to private. So you don't have to worry about it happening. So here they're creating it and then they're just getting access to it. The difference between what we're doing and what they're doing is we're making ours public and they're using an accessor method to get it. So they're calling, so where we would do GUI manager dot instance dot whatever, they are doing GUI manager dot get instance dot whatever. It's the same thing, but they're doing it. I guess this is technically better because it's preventing you from doing anything with that instance variable, although it's the same thing. It's literally the same thing. It's up to you. Hang on, I'm reading. This looks like an alternate way to do it. Private static instance. So here's the constructor. Again, they override the constructor and make it private, so you can't call it from another class. I've never seen this static block initialization before. That's a new one on me. Here's another way to do it. This is actually a good idea too, even though they call it lazy. Basically, the way it works is the first time you try to use it, it'll create it if it doesn't exist. And if it does exist, it'll just return it. This is a good way to do it as well.
So that's basically like yours in the Unity right here, the lazy initially.
It's similar. The difference between this one and what I'm doing in Unity is I'm creating it automatically in the beginning, and this one doesn't create it until you try to use it.
Okay.
Which this is probably even, there's a lot of good things about doing it this way. Doing it like this doesn't create a lot of startup processes, because this doesn't actually get run until you need to use it. So until you need the class, this doesn't get run. So if you've got an application that's got like a bunch of different windows, until that one window is opened, that code doesn't get run. And so it does save on startup costs like that. The downside to this is that on more complex applications, if you need certain code run to maybe you have some sort of data that you need to kind of keep in the background, you might need it before that particular window gets opened, if that makes sense. And so there's a bunch of different ways to do it, but what you saw me do is what you guys should be doing. So it's like, okay, we went over singletons in class. I've got an example of how it was done in C#, specifically in Unity. How do I do this in Java? And we looked and we saw 3 good ways to do it. All of these are fine. And then, I mean, it even goes on to explain all kind of different stuff, different ways to do it. So the internet has lots of great resources. And so in this case, to answer the question, and the question that kind of caused us to go look that up is, how do we destroy in Java? And it looks like you don't need to destroy, you just prevent it from being created again. This is a little bit different because in Unity, whenever there are objects that they're called game objects, but you attach scripts to physical objects in the game. And so if you have typically when the object gets created, any script on it gets automatically run. And so what this does is it prevents unnecessarily objects from being created. So when I say destroy, it would literally destroy the game object that contains the script. It's a Unity only thing, so you don't need to worry about it. In older languages like C++, you would actually destroy the memory location. You wouldn't destroy the memory location, you destroy what's in the memory location. Modern languages have garbage collection. So if you have and you guys went over this in your 12.13 and 22.14 classes, right? The idea of, if you have a reference variable that's pointing to an object, or you have a pointer that's pointing to an object, and that reference variable changes and is no longer referring to the object, and the object's just sitting in memory with no variables pointing to it, you've essentially lost access to that object. And so that's what a memory leak is. If you have that happening over and over again, you get all these objects in memory with no way to access them, and it's taking up a bunch of memory and there's no way to fix it. Garbage collection will come by and clean up those objects, but in older languages, you didn't have that. Okay. Are we good with that concept? The idea of garbage collection? Okay. I never know to what degree you guys are familiar with concepts, and so I want to make sure I don't gloss over something that you're like, I've never heard of that before. So your other instructors did a good job then. Okay, so and that's essentially it. So what we have at this point is, now we are sure that we have a single instance that's automatically going to get created, and if anything tries to get created after that, it's going to get destroyed, and so we're good there. Okay. Let me save this and we'll go back here. Now, let me give you an example. Really useful C or Visual Studio is find in files. Everybody's familiar with Control F, where you search, I wonder, where do I use the word in it? It'll find it in the script that's open. If you hit Control Shift F, it'll pop this up. And what this will do is it will search every script in the project for this. I use this all the time because in Access Football, for example, I have, here's the actual source for Access Football. Here is the folder that contains the scripts. Okay. And so these are all scripts. And so when I'm looking for something, again, these are all scripts. When I am looking for something, it's not like I've got 6 scripts that I can just look through. It's a lot. So being able to search and go through all of the codes at once is very helpful. Okay. It's a lot. So I want to see where I use this. So for example, let's open up our second script, which is going to be the main menu. All right. So what we have here is, we're looking at 2 scripts. We've got main, because we have GUI manager, which is the overarching manager for all of the individual windows. And then we have main menu. What we are looking at here is the main menu. It is, you can think of it as like the title screen of the application. It's where it's the main hub. And from there, you're going to go to all the individual windows. Okay. And so from the main menu, you'll get to the meal calendar, the meals menu, the side items menu, and you can exit. Those are your 4 options from where to go from there. And so, like I said, each of these menus is controlled by a separate script. Okay. And you can see, as I show and hide these, each of these is controlled by a separate manager script. And the first one we're going to look at is the main menu manager. Okay. So again, big picture, this is what I want you guys to get so far. It's a good idea to have an overarching manager script that has access to all the individual ones. Okay. That overarching one, which we call GUI manager, should be a singleton. Then that means, because it's a singleton, and I'm going to show you how this works in just a second, we can then access any of the sub windows that the overarching one has access to. And it makes it really, really easy. All right, so I'm going to open up main menu manager. Okay, and so we've got 2 things. Here's GUI manager. We just went through this class. It creates a singleton. And now we've got main menu manager. Okay. I will probably go through and comment these a little bit. I didn't comment them a bunch because, like I said before, I didn't expect anyone to ever look at this. But I will say this. Using these regions is super helpful. Does Java have these regions? No. Okay. Basically, they allow for categorization. And so the way that works is you just do #, or I guess hashtag for you young folks. And then you put the word region, and then you can put whatever you want. And then you need a corresponding end region, and that's it. And what that allows you to do is it allows you to just block your code off. Okay. Which I use all the time for categorization, because, for example, here's Access Football code. Get to a larger script. This is a class that manages part of the AI for what the players do on the field. Okay. And so you can see I've got it set up into a bunch of different regions. Okay, so here's the code for setting up a defensive play. All right, here's the code for when you're on defense and you're running just the main logic that you're going through. Okay, so it's helpful for organizing. I mean, this particular script has almost 5,000 lines of code. So it's helpful when you get into larger code. Go away. Okay, so let's take a look at this class. I'm going to open up all of these windows. Okay, now, first thing, and again, this isn't necessary, but it's along the lines of commenting. I am very particular about the code and how it's set up. I like it a certain way. And I understand not everybody's like that. And so it's a style. If you don't want to use the regions, don't use regions. But you do need to comment your code, at least minimally. I don't know if we've talked about this before, so I apologize if I'm repeating myself, but here's what I'll say about comments. Your comments should be a balance between providing too much information and not enough information. Providing too much information means you're commenting stupid things. Like, don't do that. Okay, if I read the line of code, the comment shouldn't be a proxy for what don't do it. Like that, the whole idea of comments is that if I read that line of code, the comment helps me understand what that line of code does. Okay, not simply a repeat of what the code says. This does nobody any good. Okay, meal database dot load database should be pretty obvious what it's doing. Okay. Now, if there's additional information that needs to go along with that, then do that. Okay. In fact, I may regret doing this because I don't know exactly what we're going to look at. But let's look at the actual code. Somebody pick a random region and we'll look at the code for there and we'll look at actual comments that I put in. No, rephrasing isn't a good thing. The real estate on your page is important, and you don't want to clutter it with a bunch of stuff. Like a good programmer is going to name their variables and name their functions and name their classes in a way that matches up with what their actual function is. Okay, and this goes along with like when you name your functions, they should be verbs, they're actions, they do things. Okay, and so when I read a function name or a method name, that should give me a good idea of what that code is doing. Okay, all right, so we're going to go offense, running the ball. Now, let's look at this, for example. Okay, first thing, I don't know if Java has this or not. These are called summary statements. Is it hard to fix glitches in games? Yes. I strongly suggest using these. These are like comments for your functions or your methods. And the way it works is whenever you call this function, you know, in IntelliSense, how you're typing and you hit like use an object name or a class name and you hit dot, and then it shows you all of the available functions that you can call. That's IntelliSense. When you have a summary block attached to a function, in addition to showing you that you can call that function, it'll also show you the summary of it. And so, for example, if I'm in another script and I go to call that function, I say player AI dot find when it's private. If I'm in another part, let's say I'm here and I call it, and I say player AI dot find hole in line of scrimmage. You see how, in addition to it popping up, it's a static AI function for a runner finding a hole to run through. That it'll show you kind of what it is. So it's really helpful, especially as your program gets bigger and you can be like, what exactly does that do? It's essentially a comment for your function. Okay. And so I strongly suggest using those. I don't know if Java has that. I can look. Does Java have summary statement for methods?
So most of what you're showing us is for C#.
You said it's only for C#?
No, I was just saying most of what you're showing us in your code is for C#, or is that for Unity or?
It's for C#. This is
Okay.
I'm gonna try to avoid doing anything Unity specific.
Okay.
And because I want you guys, the reason I'm doing this is to introduce you to C#, and the best way I can do that is by showing you examples. Examples just happen to be done in Unity, and so I'm going to focus on just the C# parts. Okay, so if you look at this particular function is responsible for setting up the AI. So if you think about football, if you've ever watched football, on running plays where the quarterback hands the ball to the runner needs to try to get as far forward as they can. So they typically have to run through a lot of large people trying to tackle them, which includes avoiding the players on their team in addition to the players on the other team. And so what this function does is it basically runs the AI for telling the runner where there are players and where they should run. Okay, without getting into all the specifics, we can look at the comments that I've put in there. So for example, let's look at this first one. So we're starting at the left side of the line of scrimmage. Okay, when I look at this start position, that comment just says we're starting at the left side. Okay, as opposed to, am I starting in the middle? Am I starting on the right side? It just tells me we're starting on the left side. Now we get to this big for loop. Okay, and what this for loop does, it's called soccer. And we're talking about football, like the real football. Thomas. All right, the way this works is there's essentially, it runs a series of visual checks. We start way left and we go all the way across. And each of these iterations performs a different visual check to see if anyone's at that position. And so that's the only comment I put. We're going to perform a series of raycasts. And a raycast is just a term that means we're going to check to see if something exists in that position. Now, again, we've got some simple comments here, but look at this one right here. And this kind of gives you a good idea of what I mean. This line of code wouldn't necessarily make sense to somebody if they just read it. Okay, physics.raycast and then some information. Obviously, we're performing a raycast, and a raycast, like I said, is simply a check to see. It shoots an invisible line from one place to another, and it will return anything that it hits. Okay, it's a game development thing, but that's not important. Look at the comment that I put. The comment really helps us understand what that line of code does. Okay, are there players at that location? If I put a comment and I said, does a raycast from cast location to cast direction, that doesn't help as much as why are we typing that line of code? Like, what is that line of code doing? Not literally, I'm going to reword what the code says, because if I come back and read this in a month, I'm going to say, well, duh, but why am I doing that? Okay. And so you want to make sure your comments aren't simply a rewording of what the code language says, and it provides better information about what's going on there. So for example, if hit AI is null or it hits the player with the ball, we're going to say that's an empty location. It didn't actually hit anything because the runner wouldn't want to avoid himself. Okay. Hit an offensive lineman. Okay. Jacob. Do I have a hand that is larger than that? Nope. No, dang it. Jacob. This is the correct way to do it. Do you have any idea how much bigger your scripts would be if you put the curly braces on the line below them? Just like seriously, that would add so many lines of code, it wouldn't even be funny. Unless your program has a strong correlation, like the coolness of the program correlates strongly with the number of lines in your code. Maybe that's like, oh, just type this code. It has 12,000 lines, but there's, most of them are just empty lines because of curly braces. I'm just saying. Twitter? I don't get that reference. Somebody have to explain it to me. You have to remember I'm old. All right. So anyways, back to this. Commenting code. We got sidetracked. Commenting code. Make sure your code comments are helpful, not simply just like obligatory. Like, oh, typed a line of code, I have to comment it. I don't know what to say, so I'm just going to say what is so obvious that anybody could see it. Don't do that. Okay. I gotcha. That makes sense. So here's the thing. I kid a lot about the curly braces. You put them wherever you want. As long as you're fine being wrong if you put them down here. Okay. I've even seen some people do this. If you want to put them here, that's totally fine. This is how I've always done it. This is how I like it. I'm used to reading code like this, but despite what I joke about and despite what you were taught, there is not one correct way to do it. I will say this though. Some companies have coding standards and formatting standards. So if for whatever reason you get hired at a company where you're coding, they may very well tell you how to do it so that all their code looks the same, just so you know. I'll say this. Yes, you need to use comments, 100%. No, you don't need to use regions, although I would suggest it. There's no reason not to use them. If your scripts are really small, like 50 lines of code, you don't really need them. I got used to using them, and I like the organization and categorization, so I use them. But it's a good idea too. It's a good habit to get into. I'll say that. Okay, so moving on. So here's how this works. We have this init function that gets called. Notice this doesn't happen in awake like the other one does. So this doesn't get called automatically based off of the script, but it does get called from GUI manager in start. So it effectively gets called as soon as this script gets run. Second thing I will say, C# has, or this is a Visual Studio thing, this is an amazing feature that it'll show you every place that this method gets called. Java may have this in certain IDEs, but this is super helpful. So I know that this function only gets called one place, and I can click on here and it'll take me exactly to where it gets called from. Super helpful, especially as you're trying to track values and that sort of thing. So another good reason to use C#. All right, so this init method gets called as soon as the GUI manager start function runs. And we do two things. The first is we load the database. We're not going to get into that code right now. We will get into it when I show you guys how to do reading and writing to and from text files, because that's exactly how this works. The meals and the side items, all of those get written to text files and they get loaded back in when the program runs. You can see that gets loaded right here. And then I call a show window function. Okay, and all this does is it literally shows the window. Okay, this is Unity specific code. Okay, this set active literally means turn it on. And so if we do set active true, that means we show it. And we do set active false, we hide it. And so it's literally like checking and unchecking this. Okay, that's the difference. So whatever GUI application that you are using, or whatever GUI package that you're using through C#, if you're using C#, it'll be Windows. If you're using Java, I'm not as familiar with, it's been a really long time since I've used GUI in Java, but I know there's several that exist. It's as simple as turning it on. Yeah, just go to Unity's website. Again, I don't want to get into too much Unity specific stuff because it's outside the scope of what we're covering here. But I will tell you, hey, this is Unity specific. You need to find the C# specific or the Java equivalent of that. Okay, so all we're doing here is when the program starts, we load the database and then we show the window. Okay, now here's where we get into the singleton stuff, and here's where we'll finish up here today. All right, now when we click on these individual buttons, different things need to happen. So for example, let me run this and I'll show you. When we click on meal calendar, two things happen. The first is, so I'm going to go back. The first is the main menu, which is this, what we're seeing here, it gets hidden. Okay. The second thing is the meal calendar menu gets shown. One gets hidden, one gets shown. It happens at the same time. Okay. So those two events need to happen when we click on this button. Read and chat. Are we allowed to use WPF or Windows Forms? Some of that code isn't C#. Yes, that's fine. That's fine. You can use that. Those two things happen. So let's look at how we actually achieve that. Now, first of all, how you link clicking buttons to functions depends on the language. It depends on how you have it set up. There should be tons of tutorials on how to do that. It is really simple. Sometimes it involves just adding a listener, which is like a method that you add to a particular button that listens for or waits for, checks for certain events to happen, like clicking on the button or mousing over the button or something like that. Again, we don't need to be super fancy. As soon as you highlight it, or as soon as you click on it, that's when it's going to do. Reading chat. So are GUI text and styling all done in the same file? It depends. I believe in C# you'll actually create, you might be able to create them in the IDE and style them in the IDE, similar to like old school Visual Basic, where you would like create a button and then like add the text to it and pick all the text and the font and the size and that sort of thing, and then attach code to it. It depends on what you want to do. Again, part of the reason I don't have more assignments is because I want you guys to be kind of diving into how to do this stuff. And so I give you lots of options, but with that freedom comes a little bit of requiring you to figure some stuff out on your own. The counterpart to that is I don't give you as many exams and assignments to make sure you guys have time to do that. Okay. Okay, so back to the code for this. So when we click on, what are we doing? Meal calendar. This function gets called. Okay, the reason it says 0 references right here is because this code for calling this method is attached to the button, and it can't, or Visual Studio can't see that. But I've got that set up that when you click on the button, we call Open Meal Calendar. Okay, now two things happen, and we see that right here. Again, we want to avoid doing things like this. This is the epitome of a worthless comment. Okay, obviously we don't want to. Now, if we instead of hide window, if this was called like do the thing, this is also what we want to avoid, because nobody knows what that means. In this situation, then having the comment becomes effective. All right, but you want to name your methods appropriately. Make sure they are actions, so they should all be verbs. And so we have an idea of what it's doing. So finally, getting to the point where we are looking at how singletons are used. So this is pretty obvious. We're just hiding the window. And when we hide the window, we set active to false, which literally just shuts it off. Now, the problem is we are, let me go back to this drawing. Okay, we're familiar with this by now. I'm going to do a couple things here. Blah, blah, blah. We got one here, one here. Okay, and so here we have GUI manager. Here we have main menu manager. And here we have meal calendar. Now, and here are the other window. Everybody good with this setup so far? All right. Now, because give me a different color. Because this is a singleton, that means that at any point in time, we can access this class from any script by saying GUI manager dot instance. Okay, this is how we access the singleton. GUI manager dot instance. Okay. Normally, we would have to create a reference to that script, okay, which is challenging. We would then have to pass that reference to the GUI manager to each of these individual scripts. On top of that, whenever we have a situation where one menu needs to access the other menu, we're going to run into issues. Like right now, when we say we're inside of main menu and we need to get access to the meal calendar to show the window. When we click on the meal calendar button, we need to hide the main menu and we need to show the meal calendar. And in order to do that, we need to get access to this script from this script. So what we essentially would need is we need a bunch of references going to all of these. Okay, so we need access here. This one needs to access this one. This one needs to access this one. This one needs to access this one. This one needs to access this one, and so on. And then we got to come this way. And then it's like everything needs to be public. Okay, this gets confusing and it gets obnoxious because every time you go to add a new window, now I have to go back through all my other windows and create a reference to that new window. And then the new window needs to get a reference to all of the existing windows. It's obnoxious and it's not a good design setup. Okay, so this is why the singleton is helpful. Let me go back. So here's how this works. We use the singleton reference, which is right here. This gets us access to the singleton. Notice at the top, there is no actual reference. We don't have a variable that points to it. It's not like we have private GUI manager. We don't have a reference to the GUI manager that we can access to it. Okay. Instead, what we have is this singleton reference right here. Okay, so having a singleton allows us to use that static instance, this right here, to get access to the GUI manager class without needing to create a reference to it. Then we simply, once we have access, so we have automatic access here through the singleton. And then once we have access here, then I can access this. So this prevents us from having to manually type out specific reference variables to each other window. And this is why we use this hub up here to do that. Okay. And if you notice, I'll answer the questions in chat in just a second. If you notice, go undo. If you notice, we do the same thing with all of the other ones. Okay, GUI manager dot meal menu dot side item menu. It's the same thing over and over again, and we can access all of them with very minimal code. We don't have to create a bunch of unnecessary references. And when we add new windows, it becomes really easy because we only have to add it in a single place, which would be that hub script, the GUI manager. Okay. Okay, so GUI manager, like it's not like a database, it's more like a hub. We use it to store reference to all of the sub windows. And then whenever we need to access one of the sub windows from anywhere else in the code, all we have to do is go through that hub. And because that hub is a singleton, we know only one is going to exist. And because we know only one is going to exist, we can access it using that static instance variable, which becomes really helpful. Other question, when is a singleton not helpful? So the singleton is not helpful when you have a lot of different use cases. For example, when you are setting up your code, when you're setting up your project, and you need, so I'll say this, the downside to using singletons is that setting up the project requires a lot of dependencies. So for example, if we got rid of the GUI manager, it would break the entire system, obviously, right? And there is not a lot of strongly tied together dependency here, meaning all of these sub scripts, these guys down here, they are not aware of each other, and they're not even really aware of this guy. They're accessing him, but they don't really know what's going on there. And so the downside to this is if I am creating a separate testing environment for something specific, I've got to bring over all of this code. And so this creates the downside to singletons is it really requires all of your code base to migrate with whatever solution you have. It makes your code not modular. And that is the downside to a singleton. So everything I just say, you can boil it down to your code isn't modular. Meaning this. If I have this GUI manager script and you want to take this and put it in a separate project, you're going to have a hard time picking out individual classes because all of the code is tied together, but there isn't very explicit ways that it's tied together. And so it's not like main menu manager up at the top, it says, we must have this class attached to it. Like, we need this class in order for this function to work. It doesn't have that. And so it does create a lot of vague dependencies, and it makes your code not modular. This is the downside to it. Okay. So all this current file is doing is opening and closing windows if a button is pressed. Essentially, yes. It could do more, but it doesn't, because this is a relatively simple application. If we go over to Access Football, this is a little bit more. Where are these listed? I was going to see if there was more stuff. So, for example, you can handle escape pressing or back pressing from the GUI manager. I oftentimes have these like return to previous menu things. So anytime, regardless of what menu you're in, if you press, the escape button or the back button, or you maybe have an on-screen button where you want to go back, it's helpful because the GUI manager has access to all of these individual ones. So you can do additional stuff like that in addition to just opening and closing windows, but that's essentially, that's its job. It's to keep track of all of the submenus and opening and closing, managing, making sure the correct one is shown. So everything related to that can be done in it. Okay. All right. We're at a good stopping point with this. Let me answer questions that you guys might have. Are you talking about, so that's regions, Zach? Are you talking about this thing? I don't know why these are tabbed out like that. Yeah, those are regions. I think it's a C# only thing, but it is super helpful for organizing your code. Because I spend a lot of time looking for specific things. So yes, I strongly suggest that you use those if you're going to use C#. Okay. What other questions? Okay, so let's go back to the course. Here's what you guys should be doing. Your project proposal is due next Friday. Okay, that's the first thing. Again, if you go to syllabus, it'll highlight it in gray, those things that are passed. And so we are here. And if you look right here, we have the project proposal due on Friday, January 27th. This does not mean that you should wait until the 27th to start on your program. The whole reason that we are looking at code and program design now is because I want you to get started now. Go ahead and start working on your program. I know your proposal isn't due until next Friday. Don't worry about, oh, is my program going to get denied? At the at the max, all I will do is perhaps tweak the scope of your project a little bit, but it won't affect what you guys should be getting started with right now. Okay, so make sure you get started with this now. If you are really concerned about your topic and its scope, just shoot me an email. And I can say, yes, you're good, or no, you might want to mess with this, but I traditionally or historically, I don't have any issues with the scope. If anything, I have to tone it down a little bit, but I want you to go ahead and get started. Questions for me? All right, we will finish up there for today. I will see you guys on Thursday for the next class. Y'all have a good one.
Professor.
Take
Yes.
care.
I can hear you.
Sorry. This isn't necessarily related to class, but I was wondering if you knew where I could get anti-static paper to like transport computer chips.
That's a good question. I have no idea.
Yeah.
Amazon would be my guess.
Okay, yeah, I need to ship my RAM for a replacement, so I was having trouble finding that.
I gotcha. Yeah, I'm thinking, I can't think of. I would just check Amazon. That's where we buy everything, right? And static paper. Yeah, they make these little like sleeves, because when you buy RAM, normally it comes in some sort of anti-static paper.
Yeah, it's been 2 years. I don't necessarily have it anymore.
Sure, no, I'm just, I'm like, normally it comes in these pouches. It's kind of expensive.
Yeah, I was gonna reuse like the stuff I got like my microcontrollers in, but I only found like one, and I need two, so it's
Maybe run by the tech support room. They might
okay.
have some just laying around.
Yeah, okay, I'll do that. Yeah,
Yep,
great, thank you.
you're welcome. Any other questions? Okay, all right, well, I'll see you guys on Thursday. Have a good one.